Suppose that we are given this differential equation and we need to find its general solution. At first instance, we can see that it looks like a Bernoulli expression. Bernoulli looks like this. Its form is dy over dx plus p of x y is equal to f of x y power of n. So it looks like similar. It's not linear because we have another y variable. We have 3y variable here, dy over dx, y, and y power of 3. But in the linear, we don't have y power of 3. We only have y, differential of y, and y. Any y power of more than 2 is not linear. Even in a linear form, we don't have y of n. This is in the linear form. However, this is in the Bernoulli form. This is not linear. So what we can do is we can use Bernoulli expression in order for us to solve this differential equation. First step is we need to convert this differential equation into its standard form. So let's do that. We bring the y power of 3 to the right hand side. And then we need to remove the coefficient of dy over dx, which is x squared. So we need to multiply the whole expression with 1 over x squared. So this will leave us with dy over dx plus 2xy over x squared is equal to y cubed over x squared. Now we need to simplify it. Right, 2y over x. Now, when we are using Bernoulli expression, we need to use another variable in order for us to replace our y with something, because we have y here. That's why we need to replace it. So we know that n here is equal to 3, and we need to form the substitution expression, which is our u. Let's use u. You can use any kind of alphabet. So we'll use u. U is equal to y 1 minus n. So this is actually a standard substitution equation. So our u is y 1 minus 3. Our n is 3. So u is equal to y negative 2. So we need to differentiate u with respect to x. And then we need to isolate dy over dx. Why? Because we need to use this substitution into our differential equation. So yes, I will do it here. Now we have isolated dy over dx, we can substitute to the differential equation. I will do it here. Now we need to remove the coefficient of du over dx. We need to change it again into its standard form. So in order for us to remove the coefficient, we need to multiply it with the inverse of its fraction, which is negative 2 over y power of 3. So this will leave us du over dx plus with 2y over x multiplied with negative 2 over y cubed is equal to y cubed. Since this is y cubed, so we can cancel out. Negative 2 over x squared. I will do it slowly. Y over y cubed will leave us 2 multiplied with negative 2, we get 4, and then the denominator is x y square. is equal to -2/x squared. Now, as you realize that we still have y variable here, however, we can substitute it with u, since y power of -2 is equal to 1/y squared. So here we can replace 1/y squared with u. Now we have the linear form of differential equation. So the function of Bernoulli is to convert it into a linear form by substituting it with a new variable. So we use u as our newly formed variable. Now let's continue using the linear method to solve this differential equation. We realize that we need to use the integrating factor. Our integrating factor is -4/x. So our integrating factor is x dx. Our integral of 94/x is a simple logarithmic integration. So this will give us -4 ln x. Using the power rule, we need to move back the 94 at the back of the x. So this will give us e ln x -4, and also based on the logarithmic rule, e to the power of ln will cancel out. That will leave us with 1/x4. Actually, we get x-4, and then we change it into its positive form, so that we get our positive power. We need to change the indices which is negative into positive, so that's why we get 1/x/4. Now we have the integrating factor. We need to multiply the whole expression with the integrating factor, this expression. So now, another major things that we need to know is the product rule. Actually, when we have the integrating factor and then we multiply this integrating factor with u, for example, like this is actually the product rule. If we apply the product rule, we will get the previous answer of our expanding form. When we multiply the integrating factor with the previous differential equation, we will get this. Four plus 2 based on the indices rule is 6. Now, if you don't believe me about this part, you can try to differentiate it by yourself using the product rule. Now we need to integrate this equation. With respect to the x. Differentiation of 1/x power 4u it will cancel out. So this will give us our previous form. I bring back the x power of 6 in its negative form, in its negative indices form. So this will give us -5 over x -5. I mean, not x, but 5. I want to write 5, but I was thinking about x, so I wrote the x. There is a mistake. So negative 2 over 95 is 2 over 5. Oh yeah, when we integrate we need to add the constant of integration, which is c. I bring back x into its denominator. And now we need to simplify. We bring x power 4 into the right hand side. So we need to multiply the whole expression with x power 4. We got u is equal to 2 over 5 x over 4, x power 4 over x over 5 plus x power 4c. This will give us 2 over 5 x plus c, x power 4c. Now we have u. However, no, we need to change back our u substitution back into the form of y. So previously we said that u is equal to 1 over y squared. So we can just substitute it back into our original function, our original general solution. So this will give us plus x plus c. So this is our final answer. This is our general solution for our differential equation. Basically, we use the Bernoulli method to transform our differential equation into a linear form by using introducing new variable u, and then after we convert it into linear form, we need to use the linear method, which is finding the integrated factor in order for us to solve our differential equation. So this is our final answer. Thank you for watching.